All four parachutes failed. SpaceX Dragon is falling at 300 miles per hour toward the ocean. 4 astronauts inside. No backup plan. Or is there? NASA just revealed Dragon's secret weapon, Super Draco engines. 8 thrusters firing 128,000 pounds of thrust in the final seconds before impact. This backup system was shelved for a decade because NASA called it too risky. Now it's actively flying on missions and has already proven itself in real tests. The same engines blast Dragon 1,500 meters high during emergencies, can now fire downward to save lives during landing disasters. But here's the crazy part. Most people don't even know this exists. How does it actually work? And why is this backup better than anything else out there? Let's dive right in. So how does this backup system actually work? The answer takes us back to a terrifying reality most people never think about. When Dragon returns from space, it's moving at 25,000 kilometers per hour. That's 7 times faster than a rifle bullet. The capsule is essentially a meteorite with people inside. The moment it hits Earth's atmosphere, friction ignites the air around it. Temperatures spike to 1,600 degrees Celsius, hot enough to melt aluminum instantly. This is why every spacecraft needs a heat shield, or it becomes a shooting star with a very tragic ending. But surviving the fireball is just step 1. What happens next determines whether astronauts come home alive or become another space disaster statistic. April 19, 2008, Soyuz TMA-11 was supposed to land in Kazakhstan. Instead, it crashed 475 kilometers away in the middle of nowhere. The crew barely survived. Why? A partial separation failure caused what engineers call a ballistic re-entry. Translation? The spacecraft fell like a rock. No control, no precision, just gravity and hope. Even when everything works perfectly, landing a spacecraft is like hitting a target the size of a football field, while falling from the edge of space in hurricane-force winds. Atmospheric density changes every second. Weather patterns shift without warning, and you're carrying human lives in what's essentially a high-tech tin can. So when the main plan fails, what's the backup? For over 60 years, the answer has been the same. Parachutes, giant pieces of fabric, standing between astronauts and certain death. SpaceX's Crew Dragon uses 4 main parachutes. Each one spans the area of a basketball court when fully deployed. They're designed to work in 40-mile-per-hour winds, off-angle entries, even partial failures. But here's the catch. Parachutes only work over oceans. Bad weather? Mission delayed. Astronauts wait in orbit, burning through life support, while storms rage below. NASA astronaut Tracy Caldwell Dyson described landing in a Soyuz as a train wreck, followed by a car crash, followed by falling off your bike. And that's when everything goes right. Ocean landings are gentler than desert crashes. Water absorbs impact better than solid ground. But the impact speed is still 5 to 7 meters per second, fast enough to break bones if you're not strapped in perfectly. Then came the test that changed everything. Nevada desert, SpaceX Dragon capsule, routine parachute test. Except 3 of the 4 main parachutes failed to deploy. The capsule hit the ground at devastating speed. Total loss, complete destruction. That crash revealed the industry's darkest secret. When parachutes fail completely, there is no backup plan. You're just falling at 300 miles per hour, watching the ground rush up to meet you. But what if there was another way? Deep inside every Dragon capsule, 8 engines wait in silence. They're called Super Draco thrusters. Each one produces 16,000 pounds of thrust. Together, 128,000 pounds of raw power. These aren't landing engines. They're escape engines, built for the most terrifying moment in spaceflight, when your rocket starts exploding beneath you. May 15, 2015, Kennedy Space Center. SpaceX conducted what they called a pad abort test. Translation? They strapped a Dragon capsule to a test stand and fired all 8 Super Draco engines simultaneously. The result? The capsule shot 1,500 meters into the air in just 6 seconds, faster than a Formula One car accelerating from 0 to 60. Then, parachutes deployed for a safe ocean landing. But here's where the story gets interesting. Those same engines that can blast you away from an exploding rocket can also fire in the opposite direction. SpaceX originally wanted to use Super Draco for powered landings. Picture this: Dragon descending from space, engines firing, landing gently on solid ground like a science fiction movie. NASA said no, too risky, too complex. Too many things could go wrong. What if the engines failed? What if the landing legs didn't deploy? What if the fuel ran out at the worst possible moment? So the idea was buried. Dragon went back to ocean splashdowns. Parachutes became the only option. Again. But the Nevada crash changed everything. While engineers worked on better parachutes, SpaceX quietly resurrected the Super Draco concept, but with a brilliant twist. Instead of replacing parachutes entirely, they made Super Draco the ultimate last resort. If all 4 main parachutes fail, if you're falling toward the ocean with zero hope, the engines fire at the final second. Not to land gently, not to hover gracefully, just to reduce impact speed enough that you might survive. William Gerstenmaier, SpaceX's vice president of build and flight reliability, dropped this bombshell during a press conference. We've actually flown it on several other Dragon flights before this. This is the first time it flies on a NASA mission. Wait, they've been testing this secretly on actual flights with real astronauts? The system works like this. Sensors monitor parachute deployment continuously. If all 4 main chutes fail completely, if impact with the ocean is imminent, all 8 Super Draco engines ignite simultaneously. They don't fire for long, maybe 2 or 3 seconds. Just enough to slow the capsule from certain death to might survive. It's not comfortable, it's not elegant, but it's the difference between coming home and becoming a memorial. Steve Stitch, NASA's Commercial Crew Program Manager, confirmed what many suspected. We have a unique capability for the first time on Crew 8 and Crew 9. It's an emergency contingency capability for landing, where if the main parachutes were all to fail, the Super Draco thrusters will fire right before the vehicle would make contact with the water. But why the secrecy? Why keep this breakthrough hidden for years? Here's NASA's nightmare scenario. How do you tell families that their loved ones are riding spacecraft with no backup plans? How do you admit that for decades, astronauts were essentially gambling with their lives every time they returned from space? The Super Draco backup system represents something revolutionary. It's acknowledgement that traditional methods aren't foolproof. It's NASA finally admitting sometimes you need a plan B for when plan A catastrophically fails. But there's more to this story. January 19th, 2020, in-flight abort test. Dragon was flying on top of a Falcon 9 rocket when Mission Control deliberately triggered an emergency. What happened next wasn't a controlled test. It was a real crisis. The Falcon 9 began breaking apart. Debris flew everywhere, chunks of metal spinning at lethal speeds, and the Super Draco engines had to pull the crew capsule through an actual explosion. Not a simulation. They performed flawlessly. The capsule emerged from the fireball intact. Parachutes deployed. Safe ocean landing. But those few seconds prove something crucial. When everything goes wrong, when your spacecraft is literally flying through an explosion, Super Draco engines don't just work, they work perfectly. Jared Isaacman, commander of the Polaris Dawn mission, put it best. We were always confident in the chutes, but this backup capability is pretty impressive. Impressive? It's revolutionary. This isn't just about Dragon anymore. This technology could transform how every company approaches spacecraft safety. Take Sierra Space's Dream Chaser. It promises elegant runway landings. Like the old space shuttle. Sounds sophisticated, but runways are limited. Weather delays are constant. And if something goes wrong during final approach, there's nowhere to go but down. Dream Chaser can only land at specific airports. Kennedy Space Center in Florida. Maybe Edwards Air Force Base in California. That's it. 2 options. On an entire planet. Dragon with Super Draco backup? It can land safely anywhere there's ocean. And oceans cover 71% of Earth's surface. That's thousands of potential recovery zones. instead of 2. But here's the question nobody's asking. If this technology is so revolutionary, why isn't everyone copying it? The answer reveals something disturbing about the aerospace industry. Most companies are still designing for perfect conditions. They assume everything will work as planned, then hope nothing goes wrong. SpaceX designed for failure. They assumed parachutes would eventually fail. They planned for worst-case scenarios. They built systems that turned certain death into possible survival. That's not just better engineering, it's a completely different philosophy. Let's examine Dragon's actual track record. As of June 2025, the cargo version has completed 32 missions, 20 flights on Dragon version 1, 12 flights on Dragon version 2. Perfect record. The Crew Dragon? 17 missions completed, 64 astronauts returned safely, 0 failures, 0 injuries, 0 close calls with the parachute system. Now compare that to Dream Chaser. Operational flights? 0. All their promises are based on wind tunnel tests, computer simulations, and small-scale prototypes. But here's what's really remarkable about Dragon's Super Draco Backup. It's not experimental anymore. It's operational, flying right now on NASA missions, protecting astronauts in real time. Every Crew Dragon launch since 2024 has carried this capability. That means dozens of astronauts have already been protected by technology most people don't even know exists. The backup system that could save lives in space is already working right now. While you're watching this video, there might be astronauts in orbit, protected by Super Draco engines they hope they'll never need. So what happens next? SpaceX has proven that powered landing isn't just possible, it's practical. Starship already lands using engines, proving the concept works for massive vehicles too. Could Super Draco technology eventually replace parachutes entirely? Could future spacecraft land anywhere, anytime, without depending on weather or recovery ships? The implications go beyond just landing systems. This represents a fundamental shift in how we think about space safety. Instead of accepting single points of failure, we're building true redundancy. But there's a bigger question here. If SpaceX can build this level of backup protection into crew vehicles, why aren't other companies following suit? Why are we still accepting parachutes or nothing as the industry standard? Boeing's Starliner still relies entirely on parachutes. No backup system, no emergency thrusters, just fabric and hope. Is that really acceptable when human lives are at stake? The Super Draco backup proves something important. The space industry's biggest limitation isn't technology, it's imagination. We've been thinking too small, accepting too much risk for too long. But there's one more aspect of this story that changes everything. Something SpaceX doesn't advertise, but insiders know. The Super Draco backup system isn't just about parachute failures. It's about something much bigger. It's about making space travel routine instead of exceptional. Right now, every spacecraft return is a major event. Recovery ships position themselves days in advance. Weather forecasters track storms across entire oceans. Mission planners spend months calculating perfect landing windows. What if none of that was necessary? What if spacecraft could return safely, regardless of weather, regardless of ocean conditions, regardless of equipment failures? That's the real revolution here. Not just saving lives when things go wrong, but making space travel so reliable that things rarely go wrong in the first place. And that brings us to the most important question of all. Here's what we just uncovered. SpaceX didn't just build a backup system, they built a safety revolution. While other companies design for perfect conditions, SpaceX designs for disaster. The Super Draco engines prove something profound. The difference between coming home alive and becoming a space tragedy isn't luck. It's preparation for the impossible. But this raises a bigger question about the entire space industry. If SpaceX can secretly develop life-saving technology, what else are they working on that we don't know about? And more importantly, why aren't other companies following this approach? Should every spacecraft carry backup systems this advanced? Or are we still accepting unnecessary risk with human lives? The astronauts flying right now are protected by technology most people have never heard of. But as space travel becomes more common, as more civilians head to orbit, shouldn't this level of safety be the standard, not the exception? What do you think? Is SpaceX setting the bar too high, or is everyone else setting it too low? Drop your thoughts below, and if you want to see more hidden space tech that's changing everything, there's plenty more where this came from. The future of space safety is being written right now, and most people don't even know it's happening.